morning, children. So welcome back to the organization of mathematics class. Okay. So in the previous classes, so from the last 15 days, we have discussed about the lesson trigonometry, right? Introduction to trigonometry, right? So the trigonometry, which is a new branch. I mean, for the class 10, it is a new branch. Okay, but trigonometry, the concept, it is a branch itself. It is an ancient branch, right? It is an ancient mathematics only. Okay. So for the class 10, it is new. So up to class 9, we didn't study about trigonometry. We didn't learn the name of trigonometry also, right? Till class 9. So this is new concept to the class 10, right? So in the class 10, we have learned the name trigonometry, which is a new branch of mathematics, right? So in the previous chapter, previous lesson, we have studied about introduction to trigonometry. So what are the concepts will be there in the trigonometry, trigonometric ratios like sine function, cosine, then tangent, cotangent, secant, cosecant. So these ratios expressing these trigonometric functions in terms of ratios of the right angle triangle. Say sine theta is equal to or sine A is equal to opposite side by hypotenuse, opposite of angle A divided by hypotenuse. Then cos is equal to adjacent of angle A divided by hypotenuse. So these expressing the trigonometric functions in terms of the ratios we have learned, and we have learned about the trigonometric ratios of some specified angle also. What is if the angle is some specified? Initially we have learned the general. A is a general angle. So after that we have given some specific angle, right? So 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. So at these specified angles, what are the trigonometric ratios values? So those are that also we have learned by making a table. So if you remember only a sine angle, so then we can extend that to the remaining 5 ratios, right? So that is also we have learned, like sine 0 is equal to 0, sine 30 is equal to 1 by 2, sine 45 degree is equal to 1 by root 2, sine 60 degree is equal to root 3 by 2, sine 90 degree is equal to 1, right? So we have learned that, you have to remember that. Okay, that is very useful for your applications of trigonometry also. The ratios, sine theta is equal to opposite by hypotenuse, cos theta is equal to adjacent by hypotenuse, tan theta is equal to opposite by adjacent. At least 3 ratios we should need for the applications of trigonometry lesson. Okay, so at least 3 ratios, sine, cos, tan. We need these 3. Sometimes cotangent. If it is cot, then we can express it very easily by taking the reciprocal of tan, right? So that is very easy. So at least you should know sine, tan, sine, cos, and tan for the applications of trigonometry lesson. Okay. So that is the first point. Then those specified angles, that also you should remember, at least for sine, cos, and tan. What is sine 0 degree? What is sine 30 degree? What is cos 0, cos 30? What is tan 0, tan 30? I mean, not 0, 0 is not required here. So we need 30, 45. We need 30, 45, 60. Okay. So 0 is not required, 90 is not required. Okay. For the applications of trigonometry lesson, these 2 values are not required. These 3 is enough. Okay. What is sine? What is cos? What is tan? At least for these 3. What is sine 30 degree? What is sine 30 degree? It is 0, 1 by 2, right? Sine 45 degree, 1 by root 2. This is root 3 by 2. Then cos is cos 60 degrees, root 3 by 2. Then 1 by root 2, same thing. Then 1 by 2. Okay. Then tan is 1 by root 3. Then 1. Then root 3. Correct? So at least we should have the knowledge of these 3 specified angles and these 3 specified, not specified, these 3 trigonometric ratios. Okay, at least these 3 specified angles, we should know this. So if you know this table, you can easily do the applications of trigonometry. Alright? So we'll go to the lesson and we will solve some examples, how to write the examples in terms of a diagram, then how to solve it by using this trigonometric ratios, right? So this is we have learned in our previous lesson. Okay. So here the new lesson is application of trigonometry. Application of trigonometry. So last lesson we have learned about trigonometry, how to use the trigonometric ratios, how to represent what is the relationship between the two ratios, right? So again, how to solve it, how to prove the identities, those things that we have learned in the previous lesson. Here applications of trigonometry, how this trigonometry will be useful in our day-to-day life. How can we take the applications of this trigonometry lesson that we are going to study in this lesson, applications of trigonometry. So application of trigonometry usually used by the astronauts. So why they are going to use the trigonometry? Because we can able to find out the distance of planets from the Earth, okay, which we can't able to measure it practically. So that we can able to measure it practically, but it is difficult, right? So without calculating practically, how to calculate the distance of the planets from the Earth? So that we have done it by using the trigonometry concept, right? So we can able to do this, and we can able to find out heights of the objects, or length of the objects, or distance between these two objects. We can able to find out by using the applications of trigonometry. As well as this trigonometric concept is useful in the concept of navigation and geography. It is used in the concept of geography and navigation. While doing the navigations, we are going to use the trigonometry to find out the distance between the two places, right? To obtain the distance between the two places, not by measuring practically, by using some techniques of trigonometry, by forming a right angle triangle between three places, and knowing the distance between those two places and getting the angle and applying this trigonometric ratios. So by doing this, we can able to find out the distances or length of the places, distance of the places, that we can do it by using the trigonometric concept in the geography and navigations. So we can able to use this trigonometry in constructing the map also, So those areas we are going to use the trigonometry. So we have so many applications of trigonometry, but as of now we have restricted to application to find out the heights and distance of objects. For the class 10, we have restricted our applications to the heights and distance of the objects. Okay. So to find out the heights and distance of the object, we will have some basic terms. We will understand those basic terms which are very, very important for the particular lesson. We will discuss that, then we will go further. Okay, heights and distance. Heights and distances. Okay. So say assume that we are standing in front of the Qutub Minar. Okay, we have seen the Qutub Minar, right? At least in the picture, right? So assume that we are standing in front of the Qutub Minar. You want to find out the height of the Qutub Minar without measuring actually. You are not measuring by actually, but you need to find out the distance you need to find out the height of the Qutub Minar, right? So you are standing at some distance from the Qutub Minar, right? So you know that the Qutub Minar will be a vertical. This constructed vertically, right? It is not constructed like this, right? Or it is not constructed like this, right? This constructed vertically. So let me take this straight line as a Qutub Minar, okay? Let me take it as this top of the minar. This is bottom of the kutub minar. Okay, so now we are standing somewhere else at some distance. Okay, away from the minar. Suppose we are standing here. This point represents the observer. You are standing here and you are seeing the top of the minar. Okay, and you need to measure the distance. And you need to measure the height of the minar. You need to measure the height of the minar without actually measuring this. Right? So for that we need the angle. Okay. So with the observer, I should join with the bottom. Right? So in fact this is foot of the minar, right? Let us join this. I'll call it as this is horizontal line. In fact, that will be drawn from your eye. Right? Not from your foot. That will be drawn from your eye. So okay. So that will be the horizontal line will be drawn from your eye. Okay. To the foot of the minar. Okay. So then, if you want to see the top of the minar, you need to raise your head like this, right? You need to raise the head like this, right? Upward direction. You need to raise your head like this. Okay. So then, from the eye, we need to draw a line to the minar. Okay. So this is your eye. This is horizontal line, right? So this is called as line of sight. This is called as the line of sight. This is the horizontal line. Okay. The angle between the line of sight and the horizontal line. Okay. If you are raising the head upwards, then that is called as angle of elevation. When you are raising your head like this upwards, when you are raising the head, then that will be angle of elevation. Okay, so you need to remember that this is angle of elevation. We have one more angle, so I will tell you. Okay, then you will be getting the difference between what you mean the angle of elevation, and we have one more thing, that is angle of depression. Okay, so that I will tell you. So understand what you mean by horizontal line, the line which is drawn from the observer to the foot of the object. Here the object is minar. Object is foot of minar. So from the eye of the object to the minar. So that is the horizontal line. Okay. Then line of sight. Line of sight will be from the eye of the observer to the top of the object. Top of the minar. Okay. You have to draw a line. That line is called as a line of sight. Okay, so what is angle of elevation? The angle between the horizontal line and the line of sight. If the line of sight, if you are raising the head upwards. Okay, so I will send you the definition of line of sight, angle of elevation in horizontal line. Okay, so they will say that angle of elevation. The case when we raise our head to look at the object above, right? When we raise our head, so when the point being viewed as above the horizontal level, so when the point is being viewed as above the horizontal level, if you see above the horizontal level, then that is called as the angle of elevation. Again, below the horizontal level, that is we have one more angle, that is angle of depression. We will explain after that. Okay, this is part 1. Let me take that. This is part 1. Okay, this is only a part 1. Okay, so this is angle of elevation. When you are raising your head to see the object, when you are raising your head, then the angle will be created, right? Between the horizontal line, this is the horizontal line, and this will be the angle. You have to raise your head like this. So there will be angle to be created. That is angle of elevation. Angle of elevation, right? So line of sight understood, horizontal line is understood, angle of elevation is understood, right? So In the same case, I take one more thing now. Say, suppose assume that you are standing in the balcony. Okay, you are standing in the balcony. You are standing in the balcony. Suppose assume that you are at a third floor or fourth floor. Okay, of a building. Okay, you are observing that in the ground floor or in the road there is some vehicle will be standing over there. They have parked the vehicle. Okay, so you are observing the vehicle. You are observing that vehicle. So how this that means what is the distance between vehicle from your building? What is the distance between vehicle and the building? Right. So the building which you are staying. Right. What is the distance between the vehicle parked over there and your building? So how to find out that distance without measuring actually? So there also that means you have standing in the building. You are standing in the building. That means building is constructed vertically, right? It is not constructed 30 degree. It is not constructed 60 degree. No, it is constructed 90 degree only. Exactly like vertical, right? So therefore, if it is constructed 60 degree, if it is constructed less than 90 degree or more than 90 degree, then there you can't able to apply the trigonometry applications of trigonometry, because trigonometric ratios we are using for the right angle triangle. So the building has to be constructed vertically. Of course, you are seeing almost all the buildings are constructed vertically only, but what will happen is sometimes some of the buildings are not constructed vertically exactly 90 degree. They may slightly make the difference. Okay, so we'll see that this building is constructed vertically. Okay, so this is the length of the building. So you are standing in the building. Okay, right? So let me call it as A. B. AB is the height of the building. Height of the building. So say suppose assume that we are having the third floor. We are having only a third floor. We are standing in the third floor. Okay, and we are observing the vehicle which is parked here. Okay, so assume that this is the vehicle. Draw a line from your eye to the object. Object is a vehicle which is parked on the road. Okay, so this is a vehicle now. You are on a balcony. This is a building. Okay, so this is the building. Okay, now which is horizontal line? Which is horizontal line? Which is horizontal line? Now you can observe that he is standing over there. Okay, this is the vehicle. This is line of sight. From the eye, you are viewing the object. You have drawn the line from your eye to the object. That is line of sight. Okay. Now we need to find out the horizontal line. Which is horizontal line? Horizontal line that should be from your eye to the from your eye, it should be parallel to the ground. So here it is. This is foot of the mirror. This is your eye, right? So you are standing on the ground, right? Actually, this is the ground. Right? This is the building, the foot of the building. So this is the ground where you are standing. The horizontal line is from your eye, you are drawing a line which is parallel to the ground. Right? So actually this is the ground. Here also the horizontal line from your eye. What is your eye? If you are writing a line like this, then that is not a horizontal line here. That is not a horizontal line because you will be standing on the fourth floor. From the eye, you have drawn a line that is a line of sight. Object will be at ground, right? So from the eye, you should draw a line which is parallel to the ground. Which is the ground? Now this is the ground. Right? This is the ground. Because this is the bottom of the building, foot of the building. This is the vehicle. Vehicle will be parked on the road, ground. The building is also constructed on the ground. So this is a parallel. This is a parallel line, right? So the horizontal line, you should draw a line from the observer eye, which is parallel to the ground, like this. Now this is the horizontal line. Horizontal line. Okay, horizontal line. So now again, this is part 1, this is part 2. You don't have part 1 and part 2, just make you to understand. I have divided into part 1 and part 2. Okay, so this is angle of elevation. When we raise our heads to see the object like this, there is a concept of angle of elevation. Now, you are standing on the 4th floor, object will be at ground. You need to observe the object, that means you need to lower your head. You need to lower your head. You need to down your head like this, right? So then the angle will be formed. The angle between the horizontal line to this line of sight. Here also the angle between the horizontal line and the line of sight. Here which is the horizontal line? This is the horizontal line. And this is the line of sight. The angle between the horizontal line and the line of sight. When we lower our head to see the object, that angle is called as the angle of depression. Angle of depression. Very, very important. When will be the concept of angle of depression and when will the concept of angle of elevation, you need to understand very carefully. Then only you can able to write the diagram for this question. Okay. So remember that they won't give the diagram. They won't give the diagrams to solve the problem. Only they will give the question. Diagram you need to form it. Diagram you need to form that. If you want to form the diagram, you should know the angle of depression and angle of elevation. Whether we have an angle of elevation or we have an angle of depression, which is horizontal line, right? Which is the line of sight, right? So those things you should clear. So that is what I am taking the time to explain only these 3 points, which is the horizontal line, line of sight, angle of elevation, and angle of depression. Okay, I will send you the formal definitions of angle of elevation, horizontal line, line of sight, angle of depression, everything I will send you formal definition. Now just understand what do you mean by line of sight, horizontal line, angle of elevation, and angle of depression. Understood angle of elevation? Angle of elevation, when you are rising your head to see the object. When you are on the ground, object will be at height. So you have to raise your head to see the object above the horizontal level, above the horizontal line or horizontal level, above the horizontal line. Then angle of elevation will be formed. So angle of depression will be formed when you are at the 4th floor or 5th floor. Object will be at the ground. You need to see the object in the sense. You need to observe the object in the sense. You need to lower your head like this. Then angle of depression will be formed. The angle of depression is between the horizontal line and the line of sight. Writing the horizontal line is also very, very important. Right? Writing the horizontal line, that will be from your eye. From your eye to, you should draw a line which is parallel to the ground. Which is parallel to the ground. Okay? So while writing the horizontal line for the angle of depression, which is very, very important. Okay? Here you can write the horizontal line very easily because horizontal line which is same as the ground. Okay? Right. So now, as I told you, to find out the height of the mirror, okay. So you can measure the distance between the mirror and you. You can easily find out the much distance between you and mirror. Okay. Say suppose assume that you will be standing at around 280 meters. Okay, 280 meter. So we have a measuring survey using which we can able to find out the angle. So those we have used astronomers, they are used to find out the angle, angle between the horizontal line and the line of sight by using a measuring surveyor that will use the angle between the horizontal line and the line of sight when they are measuring the distance of the planets from the earth. Okay, so this is theta. Okay, they are measuring the angle by using the measuring surveyor. Let me take that angle maybe a 60 degree. Okay, angle 60 degree. Okay, then I know that angle is 60 degree. Angle is 60 degree. Angle is ABC. ABC as an observer. C as an observer, right? C as an observer. Since ABC is the mirror which is vertically, which is constructed vertically, therefore angle is what? 90 degree only, right? Between the horizontal line and the mirror, it is constructed vertically, therefore angle is 90 degree only. All the buildings are constructed vertically only. It's not constructed like this, or it's not constructed like this. It should be constructed like this only, 90 degree. So if you draw the horizontal line, the angle must be 90 degree. Angle must be a 90 degree, right? So therefore, ABC will form a what? Right angle triangle now. ABC will form a right angle triangle now. Right angle triangle. For ABC is right angle triangle. ABC is a right angle triangle. Okay. So when we are having a right angle triangle, I can make use of the trigonometric ratios concept, right? So which is noun to me? Which is noun? So you can observe that. So this is the angle, right? Now that means this is the. Okay, I'll write one more time this. This is A, B, C. So I need to define that AB is the object, AB is the height of the mirror, AB is the height of the mirror, AB is the mirror, okay. AB is the mirror, okay. C is object, C is the observer, C is the observer. Mirror is the object, the mirror is the object, C is the observer, okay. Now, as I told you, I need to find out the height of the mirror. That means AB is question mark. AB is question mark. I should find out, right? So what is now distance between you and the mirror? You know that how much distance you are standing away from the mirror. Suppose you are standing at 280 meter. The angle formed between the horizontal line and the line of sight is 60 degree, right? So that also you know that, right? So which ratio I can make use to find out this? Okay. So angle is C. I have taken this as 60 degree, right? This is C. So if I consider this, which is opposite, so this is opposite, right? This is 90 degree. Definitely this is hypotenuse. Okay, and this is adjacent, correct? So I need to find out this AB. I know this BC angle. Now tell me which ratio which involves opposite and adjacent. Which ratio involves opposite and adjacent? What is opposite by adjacent or adjacent by opposite? Opposite by adjacent is what? Opposite by adjacent is what? Tan, right? Right? So I can use the tan here. I can use the tan. By observing the diagram, which is now, and which we need to find out, by observing that, we can make use of the ratios which we have. I have 6 ratios: sine, cos, tan, cot, secant and cosecant. Out of this, we are not going to use secant and cosecant normally. Rare, we are going to use, in rare cases, we are going to use the secant and cosecant and cot also. Right? But usually we will use sine, cos, tan. So we can easily find out if I take sine, cos, tan, right? So we know that if the problem is involved opposite by hypotenuse, then I can use sine, right? If the problem involves adjacent by hypotenuse, then I can use cos. If the problem is involved with the opposite by adjacent, then I can use tangent, right? So I know the adjacent BC, that is 280 meter. distance of observer to the foot of the mirror, and I need to find out this AB. Okay, that is involved. So opposite by adjacent. AB by BC. Right? So we know that which is tan 60 degree, right? Tan, which is okay. Let me take it as tan C, right? Tan C is equal to opposite by adjacent, right? AB by BC. Okay? Tan is nothing but opposite by adjacent. Opposite by adjacent. Opposite is AB, adjacent is BC. To the angle C. So C is, I have told you, 60 degree. I am taking, for example, I don't know that what is the exact angle that I need to measure by using some instrument, measuring instrument. That is measuring survey. I need to measure that what is the angle, right? So I am taking a 60 degree, for example. Okay. Now 60 degree. Okay. Let me take it as a 45 degree. Okay. For simplification, I am taking it as a 45 degree. Okay. Then 60 degree also I can substitute. But for example, I am taking, so tan 45 degree is how much? 1, right? So I am taking 45 degree. But you need to measure it exactly how much it is. You need to measure it exactly how much by using the measuring survey. But for example, I am taking as a 45 degree right now. Okay. So 45 degree, tan C is 45 degree, that is tan 45 degree. C is 45 degree, right? Angle C is AB. AB is AB. I don't know that right as it is AB denominator. BC. BC is 280 meter. Okay, 280 meter. Okay, I have taken a. Okay, instead of that I can take 60 degree. Okay, I take 60 degree only. Tan 60 degree only. Right? Now I continue here. Tan 60 degree. What is tan 60 degree? We know that tan is a sin 60 by cos 60. What is sin 60? Sin 60 is root 3 by 2. Cos 60 is 1 by 2. So 2 will get cancelled. What is tan 60? Root 3. Okay. So root 3 tan 60 is root 3. Substitute LHS AB divided by 280. Okay. So now 280 I can cross multiply because the distance is 1, right? So 280 into root 3, 280 into root 3, 180 AB, this is AB only. Okay? So you can write RAB is equal to 280 into root 3 value they have given, that is 1.713. 1.713. You can find out root 3 by using the long division method, right? You can able to find out the square root of 3 by long division method, but usually they will give the value of root 3 and root 2 in the question itself. So root 3 is equal to 1 point. They have given approximate value of root 3 is 1.713. Okay. They will be specifying in the question itself. In the question itself, they will specify that what is the root 3 value. Okay. So 1.73 they are given. 1.73 is 1.73. Okay. Root 3 is equal to 1.73. So 280 into 1.73. You have to multiply that and you should write the answer. What is 280 into 1.73? Okay. So that answer to use the length of the and height of the EB. S is supposed to 280 into 13. Right? 280 into 13. So you can multiply that. After that you can 173 is 0. 3 is 24. 3 2s are 6. 6 plus 2 8. Okay. 7 0 0. 7 8 are 56, right? So 5. 7 2s are 14. 14 plus 5 19. 1 0 0. 1 8 8. 1 3, right? So 0 4 8 6 14 1 10 8 1 0 remaining 2 4. So how many points? 2 points. So 484.40 meter. I'm not finding out the exact height of the Qutub Minar. Okay. For example, I take AB as a Qutub Minar. Degree also it is not exactly how much degree. Distance also I need to measure how much distance come away from the Qutub Minar. if you went to the Qutub Minar directly, you stand away from say, some distance. You measure the distance, how much distance you are standing away from the Qutub Minar. Then by using the measuring surveyor, find out the angle to the top of the Qutub Minar. So you will be getting the degree angle, how much angle. Then apply this concept. So you know that this is a approximate value, not approximate value. Some example value I have taken. It is not approximate value also, right? Some value, for example, I have taken that 280 meter. We are standing away from 280 meter. So I have substituted. So in the place of 280, how much we are standing substituted? Tan 60 degree, how much you are angle getting? The same angle you substitute and multiply that, you will be getting the height of the mirror. So you didn't measure the height of the mirror. You didn't observe the or you didn't measure the height of the mirror by using the tape or using some instruments. Without measuring the height of the mirror, by using the trigonometry concepts, by using this idea, you have find out the height of the mirror. A is the height of the mirror, right? So that is the applications of trigonometry, which we can able to find out the height and distance of the object, right? So there also we can able to find out the distance of this vehicle from the building. It is how much distance it is there from the building, that we can find out by using the trigonometric ideas. Again, it is very simple, right? So this is angle of depression. This theta we can find out, right? So then again we can observe the observer. We can take this as C, right? So then we can form a triangle, again right angle triangle. Then we can apply the concepts of ratios, and we can find out the length of the distance of the object from the building. Okay. So you can ask me, sir, vehicle will be around some distances from the building. We can go on directly. We can measure the distance between the building and distance between the building and the vehicle, right? So all right, that is very easy. The vehicle will be around some distance. We can go instead of taking all these concepts and applying trigonometry concepts and all. You can go and measure it very easily. Say suppose assume that you are standing here. You are standing on the one side of the bridge, and you need to find the length of the what is that? Length of the dam, right? There it is very difficult to find out the length of the dam. You can't able to walk on the what is that? Water, and you can't able to measure the distance, right? So there we can able to use the concept of trigonometric ideas. So just for example, I have taken this. Okay. So for this, measuring the distance between the building and the vehicle which is parked at some distances, no need to use this concept. For example, I have taken this. Okay. So this is one of the examples. We can use it like this. Say, I have taken a vehicle here. So assume that in between you have something else which you can't able to measure it. In between you have a dam. So there you can't able to measure you can't able to walk on that. So there you need to use this concept of trigonometry, right? So we'll see. We have so many examples on this lesson. Okay, all are like either angle of depression or angle of elevation only. Okay, either angle of depression or angle of elevation concepts only. So we will come to know that where we have to use the trigonometric ratios and which ratio we need to use, how to find out the missing side and how to find out the missing side and how to find out the missing side. Those things we will see in this lesson. Okay. Okay, I've given some brief introduction to the applications of trigonometry in today's class. So in the next class, I am going to explain a problem, how to take the diagram of the given problem, right? How to draw the diagram by using the given data, and how to find out the either height or object or distance between the objects which is asked in the question. Okay, so there will be one question, one 3 marks question will be there from this lesson. So it is compulsory. So it is very easy. They are not going to ask a very difficult question for you. They are going to ask a simple question only, right? Which is based on either sine, cos, or tan. So it is very easy. You need to form a diagram by reading the question. And if you draw the diagram, then it is 50% of the problem is done. Then remaining is only thing is you need to use the ratios. Okay. So we'll see that we'll take a problem and